Okay, dear students, okay, now obviously you have learned about the proofs in this plane geometry, right? And some of you might find it a little bit difficult in the sense that you probably didn't know where to look for the required clues, right? So I was just sharing with one student or two of them, in fact, is like how you can further improve your skills, in the proofs in plane geometry. Now, already explained to you is that you need to have your basic concept for circles, and there are additional things that you need to learn, right? So you have learned about this midpoint theorem, right? And also you have understood about this tangent-secant theorem, or we call that the angles in alternate segment, right? Now there are some other theorems that I would like to share with you, which you must actually know. Alright, although at school, or rather most of the schools, they don't talk about this, there is a need for you to know this because usually this type of questions will ask for this type of required so-called similar triangles type of questions, right? So the very first thing I want you to focus is the intersection chord theorem, or we call that the intersecting chord theorem. In the sense that if you notice, right, let's say for instance this circle, we have got two chords and they intersect at P. Now, if you look at this straight away in your mind, you must already see that PA, which is actually this black line, times PB, the whole of the chords, is equals to the other chord, PC times PD. Alright, you must actually remember that. That means the two parts of this chord, when you multiply them together, is equivalent to the other two parts. Now you might ask, sure, why is it like this? This is due to the similar triangles that you can see. For instance, if I connect the chords very clearly for you to see, you will notice that there is this vertically opposite angles, and there is also what we consider to be the angles in the same segment. So let's say this is the segment that is separated. You can see that this and this angles are the same, right? They are angles in the same segment. So having two angles means that there is actually a similar triangles, and due to that you can see that PA times PB is equivalent to PC times PD, okay, if you do the proportion check, okay. So you must know this. At the back of your mind, you must have this, okay, available to you, okay. So students, this is the very first thing I need you to start recognizing and to be very mindful of, okay. And then the second one is actually going to be this one over here. Let me just try to put that to you. Now this is called the Tangent-Secant Theorem. Okay, don't ignore the power theorem. I just want you to focus on this word called Tangent-Secant Theorem. Now, it is not your tangent-chord theorem. Right? Your tangent-chord theorem is basically angles in the alternate segment, remember? Now the question is this, but it is related to your Tangent-Secant Theorem. Because if you notice, right, questions will always be asking like this. Okay, let me just expand this and let you have a look at it, and you will know why I'm saying that. Okay, you notice every time they ask a question, there will always be a vertex that's sticking right out over here, and this actually calls for something that you need to know about these similar triangles. Okay, for instance, okay, I was just sharing with one of the students that if I connect the triangles over here, something like this, it's not straight. Now you will notice that I can actually use triangle ABP. Okay, now I can say that triangle ABP, right, is similar. Okay, now catch the key thing now. Similar to triangle. Okay, catch this now. CAP. Okay, So you might ask, sure, why is that so? Now this is due to, if you notice, this is a common angle. The common angle in triangle ABP. Okay, and there's also common angle over here. Notice this is actually shared by CAP. So this is a common angle. That's one angle already, right? The next thing is, as we have just learned about this angles in the alternate segment, can you all see these two are the same? Notice. So basically, right, CBA, right, or we can say maybe a PBA to be sure. Okay, PBA is equivalent to CAP. So having these two angles, right, means that they are similar, and because of that, there is a theorem that results in this. So you will see that they will in fact ask you to prove the theorem instead. Okay, so when they ask you to prove a theorem with a chord and a tangent involved, okay, look out for this, and this is called the Tangent-Secant Theorem. Okay, what does it mean? The Tangent-Secant Theorem means that, okay, a BC, alright, and CP. So basically it's something like this, okay, BC times CP is equivalent to, okay, in this case it's AP squared. Alright, you must know this, okay. This is by default the Tangent-Secant Theorem, okay. And of course they will actually write something like this, and when they write something like this, and you can see that I would like you to look out for this, you know, so-called theorem that is actually existing, which means that there is actually a similar triangles here. Okay, do catch this, okay, and when it comes out, do not waste time to reinvent the wheel. Look out for this common angle and your alternate segment angles, okay, which result in a similar triangle. Okay, alright, I will share more, but for the time being, this is what I want you to know. Okay, alright, have a good time. I'll see you guys soon. Take care. Bye bye.